There's a moment in physics history almost nobody talks about. One of the smartest humans who ever lived stood in front of a room full of people, looked at something as ordinary as a beam of light, and basically admitted he couldn't explain it. Not wouldn't, couldn't. His name was Richard Feynman, the guy who could explain almost anything to almost anyone. The man who won a Nobel Prize for the physics of light itself. This is the same guy who figured out why the Challenger space shuttle blew up by dunking a rubber ring in a glass of ice water on live TV, and even he, looking at plain everyday light, said out loud that if you ask why it behaves the way it does, his words, go down the drain. So here's my question for you. If the master himself hit a wall, what is light actually hiding? Stick with me, because the answer is stranger than anything they taught you in school. Okay, let's rewind. You probably learned that light is a wave. Then maybe a teacher told you actually it's a particle too. Tiny packets called photons. And they gave that a fancy name. Wave-particle duality. Said it like it was a solved problem and moved on. But that name isn't an explanation. It's a label we slapped on a mystery so we could stop feeling uncomfortable. Because the real question was never, is it a wave or a particle? The real question is, how does a single photon know where to go? And that is where it gets weird. Let me show you with something you've done 1,000 times. You look in a mirror. Light leaves your face, hits the glass, bounces back into your eyes. Simple, right? Straight line in, straight line out. Angle in equals angle out. Every textbook draws it that way. But here's what those textbooks don't tell you. That photon didn't take the straight path because it was the shortest, according to Feynman's own theory, the one that actually works, the one we use to build lasers and the chips inside your phone. That photon took every path. All of them, at the same time. I need you to sit with that for a second. Not, it might have taken a few different paths. It took the path straight to the mirror, and the path curving off to the left corner, and the path looping up toward the ceiling, and the path that goes almost behind you first. Every possible route through space all at once. Feynman called this the sum over histories, and it sounds like science fiction, but it's the beating heart of how light actually works. So now you're probably thinking, okay, that's insane. But if light takes every path, why do I see one clean, straight reflection? Why isn't it a smeared, blurry mess? Great question. Hold that thought. Because the answer is the twist that changes everything. Feynman had this beautiful way of picturing it. Imagine every single path the light could take, and for each path imagine a tiny stopwatch, a little spinning arrow that turns while the photon travels. Different paths take different amounts of time, so their arrows end up pointing in different directions. Now here's the magic. To find out what light actually does, you don't pick one path. You add up all the arrows, and when you add them up, something incredible happens. The weird, long, looping paths. Their arrows point in random, scattered directions, so they cancel each other out. They vanish. But the paths clustered around the straight shot, the quick, direct ones, their arrows all point roughly the same way. They add up, they survive, and that surviving bundle is the straight line you see in the mirror. Do you feel how sneaky that is? The straight path isn't chosen. It's what's left standing after all the other possibilities delete each other. Light explores everything, and reality is just the leftover. That is not how anybody thinks the world works. But that's the theory Feynman built, and it predicts experiments to 11 decimal places. It is arguably the most accurate theory in all of science. But I promised you it gets stranger, and I keep my promises. Because here's the part that genuinely bothered Feynman. Take a piece of glass, like a window. Shine light at it. Most of the light goes straight through, but some of it reflects back. That's why you can faintly see yourself in a window at night. Roughly 4 out of every 100 photons bounce back. Now here's the question with no comfortable answer. Take one single photon. Just one. Will it go through the glass, or will it reflect? And Feynman's answer, the real one, the honest one, was, there is no way to know. Not we haven't figured it out yet. There is no reason. The universe does not store a hidden fact about which one that photon will do. It's random, all the way down to the deepest level we can probe. Feynman said this openly, and you could feel it eating at him, because Feynman hated hand-waving. He wanted mechanisms. He wanted why. And light looked him dead in the eye and said, I only do how. Why is off the table? Let that reframe everything for you. We tend to think the universe is a machine. Push here, a gear turns there. Everything has a cause you could trace if you were just smart enough. And Feynman was smart enough for almost everything. But light showed him a wall, a place where you can predict the odds perfectly. Predict what 1 billion photons will do with insane accuracy. But you can never ever say what one single photon will do. The precision is total. The certainty is zero, both at the same time. Now, quick gut check. Are you still with me? Because this is the exact spot where most people's brains try to bail. They go, there has to be a hidden reason, some tiny variable we just can't see yet. And you should know, smart people chase that idea for 100 years. Einstein himself hated the randomness. He said God does not play dice with the universe. So physicists designed real experiments, actual lab tests, to check whether there's a secret hidden layer underneath, quietly deciding each outcome in advance. And the results came back, and the hidden layer, it isn't there. Reality really is like this. On this one, Einstein was wrong. The dice are real. Let that land for a second. And if you think that's the strangest thing light does, I saved the wildest for last. There is one experiment, Feynman said, contains, quote, the only mystery in all of quantum physics. Just one. And it's almost stupidly simple. You take a wall with two thin slits in it, side by side. You shine light through onto a screen behind it. Now, if light were just tiny bullets, you'd expect two bright stripes, one behind each slit. And that's it. But that is not what you get. You get a whole zebra pattern of bright and dark bands stretching across the screen. Bright, dark, bright, dark. That pattern only makes sense if the light went through both slits at once and interfered with itself. The crests and troughs of a wave adding up here, canceling out there. Fine, okay, so light's a wave. Mystery solved, right? Not so fast, because scientists turned the light down, way down. So dim that only one single photon goes through the entire setup at a time. One lonely particle. It hits the screen and makes one tiny dot. Then another, random little dots, one at a time, like the first drops of rain. And you'd think, okay, single particles, no wave, no pattern, but you let it run dot by dot by dot, thousands of them. And slowly out of all those individual specks, the zebra stripes appear again. The bands come back, which means each single photon going through completely alone, with nothing to interfere with, somehow went through both slits and interfered with itself. One particle, two slits at the same time. And here's the kicker. The moment you place a detector at the slits to catch it in the act, to see which slit it really goes through, the stripes vanish. The photon snaps back to being a normal particle again. It's almost like light knows when it's being watched. Feynman looked at this and said plainly, nobody understands it. Not him, not anyone. You cannot explain it in terms of anything else. You can only describe what happens. So let's come back to Feynman standing in that room. Why did he say you'll go down the drain? Because he understood something most people miss. He could give you the recipe. Add the arrows, cancel the path. Compute the odds. He could teach you to get the right answer every single time. But the second a student's hand went up and asked, but why? Why does the photon take every path? Why is it random? He knew there was no floor under that question. You just fall. There's no deeper story waiting at the bottom. The how is spectacular. The why does not exist in any form a human brain was built to accept, and I think that's the real truth about light. Not that it's a wave, not that it's a particle. The truth is that light is the place where the universe stops explaining itself. It's the edge of the map. And the greatest explainer who ever lived walked right up to that edge, looked over it, and had the courage to tell his students the one thing scientists almost never say out loud. I can show you what it does. I cannot tell you why. Nobody can. So the next time you flip on a light, the next time sunlight hits your window and you catch your own faint reflection staring back, remember that light just quietly traveled every possible path across the room, canceled almost all of them out, and handed you a clean straight line like it was nothing. And whether any single photon chose to bounce into your eye or pass right through the glass, not even Feynman could tell you why. If this rewired your brain even a little, do me a favor, tap that like button. It genuinely helps the channel grow more than you'd think. Subscribe if you want more physics that actually messes with your head. And tell me down in the comments, does the randomness of light freak you out, or do you find it kind of beautiful? I read every single one. I'll see you in the next one.